So in this video, we will be printing a simple Hello World program on the terminal. So for this, let us open the file. So this is our code. So now let us write a simple RISC-V assembly program that prints hello RISC-V world to the standard output. This will give you basic understanding of how to interact with the system at a low level. So we have started with this comments. So these are comments explaining the purpose of our program. Comments are important because they help anyone reading the code understand what it does. Here we are stating that this program will print hello world to standard output. We are also noting which registers will be used to pass parameter to Linux system calls. As you can see, we have noted which registers we are using. So this this line defines the entry point of our program by marking underscore start as global. We tell the linker where this execution of a program begins. It is like setting the starting line for our race. So here we are starting the main part of our program. The ADI function here adds an immediate value to a register. In this case, A0 is set to be 1, which represents the standard output, STD out. This tells the system where to send the output, in our case, the terminal. So then LA A1 hello world. This instruction, this line uses the LA instruction to load the address of the string hello world into register A1. This string is what we want to print out. By loading its address, we are effectively telling the system where our message is stored in the memory. Then next instruction ADI. Here A2 is set to 20, which is the length of our string. This is necessary because the system needs to know how many characters we need to print. And then A7 is set to 64, which is the system call number for the write function in Linux. System calls are used to request services from the operating system. In this case, to write data to std out. Then we run eCall. So eCall is the instruction that makes the actual system call using the parameters we have set up in the registers. It tells Linux to execute the write operation with the given parameters. Now, after printing the message, we need to exit the program. Here, A0 is set to 0 to indicate a successful exit status. A7 is set to 93, which is system call number for exiting the program. The eCall instruction is used again to make the exit system call. So now after we finally we define our data section with dot data. Here hello world is a label for the string hello world risk hello world. The .ascii2 directive tells the assembler to store the string as a sequence of ASCII2 characters. The slash n at the end of the string is a new line character so that output will move to the next line after printing. So in this small program, we have set up the parameters for a write system call to print hello world to standard output, and then we have used another system call to exit the program. This code is a simple example of how we can interact with the system directly using assembly language. Now let us run the program. Now, how to exit this program? Let us see. First, print Control X. It will ask, do we have to save the modified buffer? We let us click on yes, and I click enter. And now let us run our commands. So here are the commands which we need to run in order to execute this hello world file. Now copy it. So our program is successfully working, and you can also run this cat hello world dot s. So let us this sequence of commands assembles our source file into a object file, links it to create an executable, and then runs the executable. As expected, it prints hello RISC-V world to the screen.